So let's, okay, like what I said, you cannot say what I wrote at the end of last video because of the software problem. So let's continue to finish that problem. So for that problem, what you can throw is this: continue to example 6. So we got this is 1/8 ln u squared plus 2, right? And minus 1/4 1/u squared plus 2 du, right? You know, you have the audio right on this part, but you cannot, you know, say what I wrote, right? So this is 1/4 1/square root of 2. No, sorry. Tangent negative x over square root of 2 plus c. So and then let's come back. So this is 1/8 and ln 4x squared minus 4x plus 3, 1/4 times square root of 2 tangent negative 2x minus 2 square root of 2 plus c. So we got the integral 4x squared minus 3x plus 2 over 4x squared minus 4x plus 3 dx. The integral is x plus 1/8 ln 4x squared minus 4x plus 3 plus 1/4 square root of 2 tangent the inverse function 2x minus square root of 2 plus c. Okay, so that's the final solution. Okay, let's continue to our case. I think it's case 4. Okay, so for this, qx contains the term like ax plus b plus c, and there is a power. The power is greater or equal to 2. Okay, and ax plus squared plus bx plus c is irreducible. But you may ask me, what if x squared plus bx is reducible? If it is reducible, this can be reduced to case 2. It means we already did that part, right? So that's why we assume it is irreducible. So for this, okay, if it contains this term, for example, you have a term like this. So this means that b squared minus 4ac is like this. And if it contains the term what we assumed, and then the partial fraction can be written as a1 x plus b1 over ax squared plus bx plus c plus ar x plus br over ax squared plus bx plus c power to r. So, you know, if you compare this case with the case 2 or case 3, I think case 3. Right, or case 2, right? Case 2, it is kind of parallel case 2, right? In case 2, you know, in case 2, the linear factors are repeated. But here, the irreducible quadratical form are repeated, right? The same, right? Okay, after I finish this case, I will summarize all cases to help you to memorize them. So let's look at an example. You can imagine how complicated it is, right? So let's look at example 8. So 1 minus x plus 2x squared minus x over x and x squared plus 1 squared dx. So let's look at this. qx is x squared plus 1 squared. This is a linear term. This is irreducible, right? Quadratic form. So if like this, and you check, this is proper function, right? Proper function. So this is 1 over 1x plus 2x squared minus x minus cubic, right? Cubic. It's still proper function. X squared plus 1 complete square. So this is a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 square. And then we multiply by x times x squared plus 1 complete square on both sides. So we multiply by x squared plus 1 complete square. We have 1 minus x squared minus x cubic. So this is ax plus 1 complete square plus bx plus c and x squared plus 1 plus dx plus ex. Right, we try to simplify the right hand side. This is a plus b x power to 4 plus c x squared plus 2a plus b plus dx squared plus c plus e x plus a. Right, and then we have a plus b is 0, c is negative 1, right? 2a plus b plus d is 2, right? The coefficient of x squared. Sorry, elective 2. Did I make any mistake? Oh, I think I made a mistake here. I always, sometimes I made a mistake on the sign. So this is positive 2 and a is 1. So by solving this system of linear equation, we have a is 1, b is negative 1, c is negative 1. That's low one, right? D is 1. So we get this. So, and then, so let's deal with this. We have 1 minus x plus 2x squared minus x cubic over x squared plus 1 dx. So this is 1 over x minus x plus 1 over x squared plus 1 plus x squared plus 1 complete squared dx. Right? So the first term, this is log x absolute value. The second term is, that's hard. Okay, let me write it outside first. X squared plus 1, but it appears so many times, right? And plus x squared plus 1 complete squared dx. Okay, let me change the color. So because I always want to finish your problem in one page. So let's deal with the first term, this term. X plus 1, x squared plus 1 dx. Right? So let's do it. This is x over x squared plus 1 dx plus dx over x squared plus 1. So the integer for the, we use this so many times before, right? The integer of this is half ln x squared plus 1, right? You just see it. U is x squared plus 1. Use the U substitution. This term is, no, sorry, tangent elective. You may say, why always write a first? Because I would like to use the arctangent, but here I have to follow the textbook. So, and then let's look at this term, x over x squared plus 1 dx, complete the square. So here, how do we do this? Here we set u is x squared plus 1, right? So we get this is half du and u squared. So this is 1 over u plus c. So this is 1 over x squared plus 1 plus c. Oh, I think I'm right. Probably not. Here I forgot a half. So half. So if we combine all them together, so we have the integral 1 minus x plus 2x squared minus cubic over x squared plus 1 complete squared dx, which is, we just combine all the term together, ln x minus half ln x squared plus 1 minus tangent negative x minus 1 x squared plus 1 plus c. Okay, that's our problems. That's all the examples. So let me save it. Okay, I think I finished all the cases here, and there are kind of extra one and extra one, so which is called rationalizing substitution. So this means that, you know, sometimes you have a term like this. This is G, like this. This is like this. There is a method we said this is U, right? Because this you compute the square root. It's bad. If we use this, we have gx is u and we get a polynomial, right? This is better for me. Okay, let's look at one example. So this is x squared, a square root of this, and x plus 2. So if you look at this, so we try to use a substitution to, you know, cancel the square root. That's complicated. You know, we said this is example line. We said u is squared plus this. So we have x plus 1 is u squared, right? X is u squared minus 1. So we have dx is d2, right? So we have this x plus 4 over x dx is u, right? Over x is u squared minus 1, and du, x is 2 du, right? Du, so we get 2u over u squared minus 1 du, right? Here, we get a proper function, proper rational function, right? So, proper or not proper? Oh, I think I made a mistake here. This is 2 times du. So u squared. So this is improper. Okay, that's improper. Okay, if it's improper, we use the long division, right? We get this is, we use long division. So we put the 2 outside and 1 plus 4 over u squared minus 4. This is 4. This is 4. This is 4. This is 4. Sorry, made a lot of mistake on this. So this is 4. All right. Anyway, so we have the square x plus 4 x dx is 2 times du plus 8 1 over u squared minus 2 du, right? So we have this is 2u plus this term. So this is 8 1 over 4 ln u minus 2 u plus 2 absolute value and plus c. So let's use a substitution because u is square root, right? This is 2 times x plus 4 plus 2 times the ln square root of x plus 4 plus 2 minus 2 over square root of x plus 4 plus 2 absolute value and plus c. So you may ask me, how do we do this? So you use partial fraction, right? This can be written u plus 2, a plus b, and u minus 2, right? This can be written as this, right? You can solve a, right? You can solve A is 1/4, negative 1/4, B is 1/4. Anyway, so and then I jumped, but you know, we already use a not partial fraction before, right? So I want to know, I want to let you know in the future if you look at a problem, it has a square root or square root like this. Compute the square root, nth square root. Okay, you try to set the nth square root as one term, and then you can cancel the nth square root, and then you will get a polynomial. We like a polynomial, right? Whenever we have a polynomials, it's easy. We have a partial fraction. Okay, so finally, let's summarize. So finally, let's summarize the partial fractions. So first, we have a function fx is px over qx, right? So case one, fx is improper. So we use long division. We get fx1 is f1x plus p1x q1x. This is proper, right? Or case 2, fx is proper, right? Means that we write the same place. We get a proper rational function, right? And then let's use the partial fractions. We have 4 cases. Case 1, qx only contains term like this: a1x, b1, and akx plus bk, right? We assume our fractions are proper here. Okay, if like this, so px over qx is proper. This can be written as a1ax like this, ak over akx plus bk. So case 2, qx may contains some term, the power is greater than 1 or equal than 1 or greater, akx plus bk rk, right? For this, it's complicated, right? px qx can be written as a1x b1, right? a11 plus a1 r1 over a2x plus b 2 r1 and continue right, and a k 1 akx plus bk and akrk over akx plus bk, right? This is case 2. Case 3, if qx contains the irreducible quadratic form like a1x plus, there are many cases. It's hard to write that term if you look at the textbook. I just say if it contains some term, for that term you have to write, you know how to write the partial fraction. For example, I say this is contains, because if you write it outside, it's very complicated. You have to combine this with case 1, case 2. You may say, does it contain case 1 or case 2? I think you understand me because we have many examples. shown before contains ax plus b plus c like this. And then if you have a term, then the QX contain a term like this. So we have the partial sum is ax plus bx. No, what I'm doing. The partial sum can be written as ax plus b over x squared plus bx plus c. This is case 3. Okay, so let's finally look at the case 4. QX contains the power of the irreducible quadratic form, for example, R, right? And then if we have like this, so we have the partial sum is ax b1 over ax squared plus bx plus c plus arx plus br over ax squared plus bx plus c power 2r. There are a lot of questions here. You may say, what if the QX contains, QX contains the linear term, quadratic term, or for the quadratic term, for some quadratic term, the power is 1, some is greater than 1. What do you do? For if your denominator contains the term which is lying in case 1, case 2, you just play case 1, case 2, case 3, case 4 separately. And then you write it as a partial fraction. Just, check the examples of what I wrote before, right? So this is a partial fraction. So I think I'll stop. I think, I will write the homework, and then post online. Okay, so. Stop share.